In this video, you will learn how to multiply and divide radicals. You will be able to learn about, or you will be able to rationalize denominators. And we're going to repeat an older objective, simplifying radicals again. So to start, we're going to look at multiplying and dividing with radicals. And a few statements here. The first one, the numbers inside the radical are multiplied or divided together. The numbers outside the radical are multiplied, divided together. One thing you cannot do is multiply the outside and inside numbers together. Outside go with outside, inside go with inside. And finally, always simplify your answers if possible. So looking at these few examples here, starting with multiplication, we have 5 root 2 times 6. There are 2 numbers outside and 1 number inside. So multiply the 2 outside. 5 times 6 is 30. Square root 2 has nothing to multiply with, so it stays square root 2. So it is 30 root 2. The second example, 4 root 2 times root 6. 4 is by itself. However, root 2 and root 6 are both inside the radicals, so we're going to multiply those together. 2 times 6 is 12. Now, the next question you ask yourself is, can I simplify the square root of 12? Well, yes. Our list of perfect squares says 4 goes into 12 3 times. So I'm going to write this as 4 times 4, or 4 times square root 4 times 3. I'm going to rewrite this over here so save some room. I'm going to have 4 times 2 root 3. The 2 came from square rooting the 4 underneath the radical. Finally, 4 times 2. 2 is now on the outside, so I can multiply it by 4, and you get 8 root 3. You get 8 root 3. And 3 can no longer be simplified to the radical, so that is your final answer. Let's move on to this fourth example. You have 2 numbers on the outside, 10 times 2, that's 20. Here you have square root of 3 times the square root of 3. So essentially you have the square root of 3 squared, which ends up giving you just 3. And if you don't believe me, square root of 3 times 3 is the square root of 9. The square root of 9 is 3, which is how I got that 3. 20 times 3 is 60. So sometimes you may start with a radical, but may not end with one, depending on the problem. This example here, we have 2 numbers on the outside and 2 numbers on the inside. However, the square root of 4 is 2. So I can rewrite this like that. And now I have 3 numbers on the outside and 1 on the inside. So 8 times 2 times 2 is 32, and then root 6 has to stay in the radical. So once more, I change the square root of 4 to 2. Then I multiplied the 3 outside numbers together to get 32. And root 6 had to stay inside because it is not a perfect square. Let's go to some dividing examples. Again, you're going to want to keep the inside numbers with inside numbers and outside numbers with outside numbers. So in this example here, we have 8 and 4. Those are both on the outside, so we're going to divide those to get 2. And root 3 is going to stay root 3. This example here, we have 2 numbers on the outside. 21 divided by 7, that is 3. Square root of 2 over square root of 2. You have something divided by itself. So these effectively cancel out to 1. And 3 times 1 is 3. This example here, you have 2 on the outside and 2 on the inside. 12 divided by 3 is 4. The square root of 6 divided by the square root of 2 is the square root of 3. 3 cannot be simplified at the radical, so we are going to leave it as our final answer. So one more time, divide 12 and 3, they're both outside, you get 4. Divide the two numbers on the inside of the radical, 6 divided by 2 is 3. Square root of 3 cannot be simplified because 3 is not a perfect square, and a perfect square root besides 1 does not go into it. Let's do one more. This last one, number 6. 32 and 4 are both on the outside. 32 divided by 4 is 8. And the square root of 20 and the square root of 5, both underneath the radical. 20 divided by 5 is 4. And 4 is actually a perfect square, so we can actually square root that, get 2, and then finish multiplying to get 16. So we just finished up our main objective, our first objective for today, multiplying and dividing radicals. And now we're going to move on to our second objective, called rationalizing the denominator. And rationalizing the denominator means taking the denominator and making it rational. And when you have a square root of a number that's not a perfect square, it is an irrational number. So in order to change it to a rational number, we need to get rid of the square root in the denominator, or the radical. So this statement says if there's a radical in the denominator, I put in parentheses bottom of a fraction, then it's not simplified. Let's change that word simplified to rationalized. It needs to be rationalized, meaning no radicals in the denominator. To do this, to simplify to rationalize, multiply the numerator and multiply the denominator by whatever the radical in the denominator is. Essentially, this is multiplying by 1. So what this means is you're multiplying both the top and bottom by the same number, and when you do that, you're multiplying by 1. So while we're changing the way the fraction looks, you're actually not changing the actual numerical value of it. And finally, always simplify your answers if possible. So if there's a radical that can be simplified, we are going to expect that you do simplify it. So look at this first example. You have 5 divided by square root 2. Obviously, there's a radical in the denominator. This is not rationalized. So what you are going to do is multiply by the denominator over the denominator. So I'm choosing the radical in the denominator, and I'm repeating it twice, up top and bottom, because this fraction I'm circling right here is 1. So while I'm changing the way the fraction looks, I'm not changing the numerical value of it. Now, why do we choose the denominator radical? Well, watch what happens. On top, it's 5 root 2. No big deal. On bottom, the square root of 2 times the square root of 2 is 2. Effectively, the denominator is the square root of 2 times the square root of 2, or the square root of 2 squared. And we've talked about this before. The square root and the square cancel each other out. Now, the denominator is a rational number, so we are done. If you had, a number besides 5 on top that you could simplify, we would expect you to do that as well. Let's look at this one here. 6 divided by square root